This is another spring mass damper initial value problem, and it's going to have repeated real roots. So you can actually have all three cases for spring mass damper. There's going to be distinct real roots, there's going to be repeated real roots, and there's going to be complex roots, and they're all going to be physically possible systems. So they'll have, a positive mass, they'll have a positive coefficient of friction, and they'll have a positive spring constant. So let's just go ahead and solve. So normal guess, we guess z equals e to the rt. So if we do that, we end up with r squared plus 6r plus 9 e to the rt equals 0. And then this factors into r plus 3 and r plus 3 e to the rt equals 0. All right, so then z1 equals e to the negative 3t, and z2 equals t e to the negative 3t. And again, we go through the same process to solve the initial conditions. So our general solution, z of t equals c1 times z1, so equals c1 e to the negative 3t plus c2 t e to the negative 3t. All right, well, we know z of 0, that ends up actually just being c1, right? We get c1 times e to the 0 plus c2 times 0 times e to the 0. The t equals 0 there kills off the c2 term, so we end up with just c1. And c1 is supposed to be 3, so we know c1 is 3. All right, well then we do have to compute z prime of t to evaluate to get the second initial condition. So that one ends up being, let's see, negative 3 c1 e to the negative 3t. Then we have to do a product rule on the next one, so c2. Let's do t e to the negative 3t. Then we get a minus. Oh, sorry, the minus was the first one there. Minus 3t e to the negative 3t plus e to the negative 3t. Right, the t turned into a 1 on the second term in the product rule. All right, well, that's negative 3 c1 e to the negative 3t. Let's just evaluate, z prime of 0, because most of the terms will disappear. So z prime evaluated at 0. Well, we get negative 3 times c1 times 1, so negative 3 c1, plus we get c2. We get negative 3 times 0 times negative 3 plus 1. So in that case, we just end up with c2. And we know that's supposed to equal negative 2. And I can also plug in, I already know the value for c1, so that's negative 3 times 3, so that's negative 9, plus c2 equals negative 2. So that must mean that c2 is equal to 7. Then the solution to the initial value problem is z of t is equal to 3 for the c1, e to the negative 3t, then plus 7 t e to the negative 3t. And we're done.